Yeah there. Recently I was working on a lot of iOS projects which relied on the concept of observable values. Observable values are basically the regular read-only values, which also has an option to observe changes in these values, which opens a door to a beautiful world of the reactive programming for the developers. And today, in 2025, we have so many native frameworks to work with the native iOS code, and it is really easy to get lost. So I decided to make this video to show you how you could make the observable values in different native iOS frameworks. And for that, I created this simple application. It's supposed to be a counter which is supposed to, well, display numbers on this view, and we could either start or stop the counter, and these numbers supposed to grow by one every half a second. The view model of this view you can currently see on your screen. So as you can see, it controls the text which is supposed to be displayed here, the button text, and also it handles the button tabs. As for a model for this view model, there is an instance of the counter which implements the observable counter protocol. So basically it provides the current value of the counter. It provides the state of the counting process to the view model, and also has two methods to either start or stop counting. If we will go to the details of the implementation, you will see that when we start the count, after some safe checks to not execute the counting twice, we are just creating a timer on the main queue, and every half a second the method increase value is executed on the counter. And in this method, the value is just increased by 1. And whenever the counter is commanded to be stopped, this timer is invalidated and removed from the memory. And that's it. If we would go to the view model, we would see that the view model reads the counter's value only once in the constructor, and it has no idea if it ever changes. So let's create an observability here, and our first technology to check would be the KVO, KVoObservation, which was implemented for the Objective-C. So let's get back to our counter. To make it work, first we need to adopt our protocol to be an Objective-C protocol. And also we are going to say that the value is not just value, that it is actually a dynamic one, so it could be observed. The observable counter itself as a class is going to be a subclass of NSObject, and its value is going to be dynamic. All right, so now let's get back to the view model, and over here we would need an instance of some kind of subscription. In this particular framework, it is named as an observation. So let's create it over here. And it has the type of NSKeyValueObservation. And in our constructor, now we are able to create this observation using the counter itself and the method observe. However, well, the counter at the moment is just implementing the observable counter protocol, and it doesn't have it. To make it possible, we need to explicitly let the view model know that the counter is an instance of an NSObject. So let's make it generic. The counter is going to be a subclass of an NSObject, and it's going to implement the observable counter protocol. So now we're going to replace the counters type, and now it is going to have this observe method. So over here, we are going to provide the property which we are going to observe, the value. And now we just need to fill the change handler, which provides the reference to a counter and also a special change structure. The change structure contains the previous and the new value whenever the change happens. However, well, to avoid any unwrapping, let's just use the counter itself. So we are going to just use the counter and reset the text for the view model. And to make it safe, first we are going to wikify self to avoid any retain cycles. And also we don't know at which exact queue this code is handled. So to guarantee that it happens on the main queue, let's wrap up this execution to a closure to be executed on the main queue asynchronously. And that's it. Let's check if it works. Nice. So I could suspend this counting, resume it, and suspend again. All right. So this was the KVO and Objective-C. As you could probably understand, not that very popular in 2025. So let's reset the changes which I've just done and try something different. Like, what would it take to implement this observability in pure Swift? Let's say that we would need some kind of observe value method, and over here we are going to have some kind of closure which is going to handle the new value of integer type, and it's going to return some instance of the value subscription. So as you can understand, we are going to implement the value subscription on our own. So basically, why we do need the subscriptions? They play a very important role. So while subscription exists in memory, the bounding between the observer and the observable also exists. So whenever it is deconstructed, the value subscription is supposed to remove this bounding between the observer and the observable. So as you can understand, we are going to implement the deconstructor for this class, and it's going to use some kind of protocol like value subscription remover. And over here we are going to just define one method, remove subscription. As you could understand, there could be multiple subscriptions for a single value. So let's use some kind of identifiers here. UUID type would be fine. Finally, to make it work, our value subscription need to know its identifier. It needs the reference to the remover. So it's going to be an instance of this type. We are going to set them up using some default constructor, and on deconstructor, the value subscription is going to just execute the remove subscription on the remover. All right. In our case, observable counter is first going to spawn our value subscriptions when the observed value is executed, and also it's going to handle the removing of the subscriptions. So it's going to implement this remover protocol. All right, let's start with the observe value method implementation. As you could understand, we need to store the closure in the observable counter somewhere. So let's create a dictionary like closures, which is going to store all the closures for some kind of ID. And initially, of course, it's going to be empty. So over here, we are going to first create an instance of the identifier, and then put the closure to the closures, right? Oh yeah, we totally forgot that the closure, of course, should be escaping. So let's put it also over here. Right, so the observed value just saves this closure to the closures dictionary and returns a subscription. To make it actually save, as you can understand, the observed value could be executed from multiple different queues. We are going to create the special queue to modify the closures. So let's name it as the closures access queue, and it's going to be the dispatch queue with some verbose label like closures access queue. And as you can understand, it is the serial one, so it's going to be safe to modify the closures within this queue. All right, and to make it even safer, let's wikify self over here. And now we need also to implement the remove subscription method, which is going to again modify our dictionary in a safe way, but this time we're going to just put nil in this dictionary for this exact identifier. All right, we have our closures, and whenever the value changes, now we are able to implement the didSet method and go for all the closures. So for each, we wouldn't care about the identifier of each closure, we don't need it, but as the closure itself, we are going to just execute each closure with the new value. And that's it on the model side. Let's go back to the view model. So we are going to have our own subscription of type value subscription, which we've just implemented. And over here, we are going to create an instance of that using the counter. So we're going to execute the observed value, wikify self for safety, receive the new value, and then modify our own view model state on the main queue using the new value and modifying the text. All right, so let's check if it works. Nice. So as you can see, it was kind of difficult because we were implementing a lot of additional stuff like subscription removing, and so on. So that's why it is always preferable to use some native framework to handle this job to that framework. So I've just reset the project again. Now let's try one of the native frameworks. Let's try the combine. And in combine, there is a special type named the CurrentValueSubject, which behaves exactly like the observable value. So basically, it's a generic type, so we can say that this is the observable values of integers. And also, well, we should specify the type of error if something goes wrong with the value. But in our case, let's just use the type never, which means that the error is not supposed to happen while working with the value. All right, so the value of the observable counter should be replaced over here. So instead of integers, we are going to use the subject, and initial value for its integer is going to be 0. When we're increasing value, we now should work with the current value subject, and to read the value from the subject, we need to use its own property value. And to write to it, we could either use the value or the method send. So we're going to send a new value to the subject. So the subject publishes the changes in the value, so we could subscribe to them in our view model. And in Combine, the subscriptions have the type of any cancelable, which means that in addition to regular behavior, which we just implemented in our own way, they don't just cancel the subscription on the deconstruction. Actually, they let the developer cancel this subscription at any point of time in the code. All right, so for the read-only operation, we need to modify this code a little bit to read the counter's value from the value of the subject. And over here, we are going to create our subscription by using the counter value sync method, which would provide us the closure to handle the new value. In Combine, we shouldn't care about thread safety that much. We could just, for example, modify this publisher or this subject a little bit by executing the method receive on. And here we are going to just provide the dispatch queue main as a scheduler. So now it is guaranteed that this receive value closure is always going to be executed on the dispatch queue main. Over here, we still need to think about the retain cycles. So let's use the weak self. And we are going to just modify the text using the new value. Let's check for any compilation issues. Nice. So it works. So that was really easy, right? And now let's proceed to the most juicy part about how we could do the observable values in the Swift concurrency. So let's go back to the counter. So in addition to value, we could specify the value stream. So the async stream of integers, which would provide the access to the changes in the value of our counter. Also, it would be nice if we would change our counter from being just a class implementing this protocol to being an actor, which means that we would guarantee a safe access to the value at any point in our code. So let's first specify the protocol that it's supposed to be implemented by actors, and then we are going also to change the type of the observer counter from the class to an actor. All right, so now let's try to implement the value stream. What is interesting about the async stream that each instance of the async stream serves only one couple of observer and observable, which means that for any new subscription, we would need to create a new instance of the async stream. So instead of being just a stored property, actually, well, I'm going to implement a computable property which creates a new async string on each read operation. So over here, we are going to create a new async string, and for that we need to deal with the async string continuations. So as you could understand, we again are going to store continuations just like we stored the closures in our own implementation of the observables. So let's create the continuations variable inside the counter. So it's going to be a dictionary which stores our exact type instances of type async string for integer continuation, and initially it's going to be empty. As this is the actor, it's also nice to have the modify methods like add continuation and remove continuations. So the add continuation is going to add continuation for a specific identifier, and the remove continuation is going to remove the continuation from our dictionary. So over here it's going to just set nil in the dictionary for this specific ID, and over here is going to set it to the specific instance. All right, now let's get back to the constructor of the async string. So first let's create an identifier for a new string, and after that, yeah, we could just add the continuation to be stored in the counter. But also we need to specify on what needs to happen whenever the continuation is terminated. And for that, well, we need to provide a specific sync closure to be handled. Over here, we are going to execute the remove continuation. So whenever the continuation is terminated, it should be removed from the observable counter. So we are going to use the identifier, but also, as this is an actor, we need to access this method asynchronously in some kind of task. All right, so we have our continuations, and now whenever the value changes, we could run through them. So something like this, continuations for each. Again, we don't care about the identifier of the continuation. We are going to just use the instance of continuation itself. And here we are going to just yield the new value to it. All right. Now we need to modify some methods of the observable counter because now it is an actor. So over here we are creating an instance of timer on the dispatch queue main, which is not a way it should be done in the async await manner. Instead, we are going to first move this execution to a separate task, and after that we are going to execute this code on main actor in a async await style. All right. Now over here we are calling the increase value on each timer call, which should be done in a separate task to isolate it from the synchronous code. And over here we are setting the timer, which also should be done in a safe way. All right. And of course, we need to execute it using the await, and that's it. Right, so we've just finished the observable counter. Now let's get back to the view model and actually implement these observations. So first of all, as you can see, we are not able to just read the values from the actor as is. Instead, we need to do it in a task. And we need to use wait word to suspend the code execution till these values are read from the actor. Here we also could subscribe to the stream of the values, but before this, let's wikify self for my safety concerns. And let's finally work with the async string like with the sequence. So for await new value in counter value stream, which is also need to be accessed with the await, we are going to set the new text on the view model using the new value. And finally, we need to modify the button did tab code a little bit. Again, we need to use the task to move the read operations from a synchronous code. So first we would need to get the state of is counting from the counter using the await. And after that, well, we could execute the change of the button text using the main actor. So if it is counting, then the button text is start, otherwise it's going to be set to stop. Let's also use the wikify here to make it safer. And finally, we need also to command the counter to either start or stop the counting. So let's spawn another task in parallel. So whenever the counter is counting, the counter would be command to stop, otherwise it's going to start. And let's use the copy of the counter actually here. And finally, let's put some await words, and that's it. Let's rebuild the project with this new code. All right. Okay, so these were at least 4 ways on how you could implement the observable values using the native frameworks in your iOS projects. I hope you enjoyed this video. If you'd like to see some other tasks being solved by me, then just put your request to the comment sections. See you next time. Cheers.